So the aim of today's marathon is to take questions from microeconomics. These are spread across different topics, and you should go ahead and you should try to solve these questions, okay? So this is the first question. Try to go ahead and first solve it yourself. In total, I will be taking 6 questions today, and we'll try to solve these questions across different topics. So first question, try to do this yourself. Let the support of a mixed strategy refer to set of pure strategies that are played with positive probability in mixed strategy. This should be let the set of. Which of the following is true for a Nash equilibrium mixed strategy? Okay, D. How about others? Let us go ahead and let us take some examples. Then we will solve this question, huh? It's not known whether it is MCQ or MSQ. Take as you like. You can take it to be MCQ for now, but even if I don't tell you whether it is MCQ or MSQ, the answer is very prominent here. Okay, let us go ahead and let us begin with some examples. पहला example देखो. I have this example where I have a prisoner's dilemma, right? And suppose I go ahead and I take these payoffs, right? So here we can go ahead and take commit, not commit, commit, not commit. If both the players are not committing to the crime, then they will get payoff of 3,3. If both commit to the crime, then they will get a payoff of, suppose, so the second best is, let me write in the right order only. This is player 1, this is player 2. Player 1 के लिए first best option is when he commits to crime and other doesn't commit to crime. So let me give this as 3 first. Then the second best is when both don't commit to crime. So I am giving this as 2. The third best is when both commit to crime. So I'm giving this 1. And the fourth best is when he didn't commit to the crime, but the other person committed to the crime and put him in jail. So I'm giving this as 0. Ye payoff, you can write it in any terms. Instead of writing 3, 2, 1, 0, you could have written 4, 3, 2, 1, does not matter. The reverse will happen here. 3, 0, 1, 2. Right? We know that we have already seen in classes that whenever it is prisoner's dilemma, we have a strictly dominant strategy. we have a strictly dominant strategy. और वो strictly dominant strategy क्या है? So when player 2 is committing to crime, what is best for player 1? Best response of player 1 to not commit to crime. Right. And when player 2 is not committing to crime, what is the best response of player 1 to commit to crime? Right. I think I have written the payoffs. This was the last one, I think. This will be 0,3, sorry. So this will be to commit to crime, and here also it will be to commit to crime. So we saw that when it is prisoner's dilemma, the best response of player 1 is not changing when the best response of player 2 is changing. है ना? तो player 1 के लिए जो best response है वो हमेशा एक ही है, that it will commit to crime, right? Same is the case with player 2 also, right? So when player 1 is committing to crime, best for player 2 is this. When player 1 is not committing to crime, between 3 and 2, this is this. So we saw that there was strictly dominant strategy in this case. And what else did we see? We saw that whenever we have such games, when we have strictly dominant strategy, that becomes the Nash equilibrium. That also we saw. And we saw that always pure strategy Nash equilibrium plus mixed strategy Nash equilibrium will be odd number. So it means that अगर मेरे पास one pure strategy Nash equilibrium आ गया है, I have got this as one pure strategy Nash equilibrium. There will be zero mixed strategy Nash equilibrium to give me an odd number. So what are the conclusions I can draw from this game? The conclusions I can draw from this game is that whenever I have a strictly dominant strategy, that goes ahead and becomes the Nash equilibrium. It is pure strategy Nash equilibrium. And in that case, I have no mixed strategy Nash equilibrium. This much is something which I can just validate. I can just verify from my game that I have here, from the prisoner's dilemma that I have here, right? So it means that now if I look into these options, try to understand these options now and try to look into these options, what can we go ahead and what can we say about these options? It says no strictly dominated pure strategy will belong to the support of a Nash equilibrium mixed strategy. तो ऑप्शन नंबर ए, इफ आई ट्रांसलेट दिस इन हिंदी, वो ये बोल रहा है कि कभी भी स्ट्रिक्टली डोमिनेटेड प्योर स्ट्रैटेजी एग्जिस्ट नहीं करेगी. नो स्ट्रिक्टली डोमिनेटेड प्योर स्ट्रैटेजी विल बिलोंग इन केस देयर इज प्रेजेंस ऑफ mixed strategy. In case there is presence of mixed strategy. तो can you understand, ये strictly dominated का बात कर रहा है, dominate करने का नहीं. The first option is saying what happens when a strategy is getting dominated. और ये बोल रहा है कि अगर हमारे पास एक mixed strategy Nash equilibrium होगा तो कोई भी डोमिनेटेड स्ट्रैटेजी नहीं होगी, मतलब किसी पे भी हम डोमिनेट नहीं कर पाएंगे. वी विल नॉट बी एबल टू डोमिनेट. होल्ड ऑन टू दिस एंड टेक टू मोर एग्जांपल्स हियर. आई एम जस्ट गिविंग यू मोर डिटेल्स. द आंसर शुड बी क्लियर टू यू, बट आई एम जस्ट ट्राइंग टू गिव टू मोर डिटेल्स. यहां पे वी हैव सीन द एग्जांपल वेयर आई हैव वन प्योर स्ट्रैटेजी एंड जीरो मिक्स्ड स्ट्रैटेजी. And this is where I have a strategy which is dominating the other strategies. Now, case 2, if you remember, we had battle of sexes. And in battle of sexes, what happened? Movie, football, 2-1, 1-2, 0-0, 0-0. we saw that there were two pure strategy Nash equilibrium, one mixed strategy Nash equilibrium, टोटल में 3 Nash equilibrium existed. और इस गेम में हमने देखा था that there was no strictly dominating or dominated pure strategy Nash equilibrium. यहां पे ये जो था ये 2-1, this is not getting dominated by any other strategy because there is no dominated strategy. The best response was changing. When player 1 was going for movie, best response of player 2 was movie. When player 1 was going for football, best response of player 2 was football. So no strategy was dominating the other and no strategy was getting dominated by other. ना dominate कर रहे थे ना dominate हो रहे थे. Neither dominating nor getting dominated by the other. Here we are saying that इस case में if committed is becoming a dominant strategy, so it is dominating over non-committed. ये dominate हो पा रहा है, it is getting dominated by committed. So not committing is a dominated strategy. दोनों exist कर रहे हैं, dominant and dominated. But here if you can see, there was no dominating or no dominant strategy. And this is the example where I have the ratio of 2:1. And one last example is case 3. जो हमारा था the example of matching the pennies or zero sum game. These are the only 3 examples you have to remember. So zero sum game में what happened? Suppose I tell head, tail. So when it was head, first player giving to second. When it was tail, second giving to first. When it was tail, second tail head different. So it was same. And when it was the same, so it was like this. Right? तो इसमें भी हमने देखा था that there was no pure strategy Nash equilibrium, only one mixed strategy Nash equilibrium, and total was coming out to 1. And in this also, there was no strictly dominated or dominant strategy. Mani, wherever mixed strategy Nash equilibrium exists, no dominating or dominant strategy exists. The best response was changing. There was no dominating or dominant strategy. So it means that the first option is absolutely correct. Option A is correct. A यही तो बोल रहा है that if there is a mixed strategy Nash equilibrium, no strictly dominated pure strategy will exist. Right? अगर प्योर स्ट्रैटेजी कोई एग्जिस्ट करती जो डोमिनेट हो रही होती स्ट्रिक्टली, तो उसके अगेंस्ट एक ऐसी स्ट्रैटेजी भी एग्जिस्ट करती जो उस पर डोमिनेट कर रही होती. एंड इफ अ स्ट्रैटेजी इज डोमिनेटिंग ओवर द अदर स्ट्रैटेजी, तो ये हमारा नैश बन के आता. बट दैट इज नॉट हैपनिंग. सो ऑप्शन ए इज द करेक्ट ऑप्शन. There is no strictly dominated pure strategy like in the other 2 example. कोई भी strategy dominate नहीं हो रहा. No strategy is getting dominated and there is presence of mixed strategy Nash equilibrium. So A is correct. Right? So answer to this question is A. Tell me if there is any doubt in this. This is a very good question which is playing around the words. Any doubt? We are clear with it? Explain D. Okay. If there is a dominant strategy in support of Nash equilibrium, mixed strategy, then there cannot be any other dominant strategy in this support of mixed strategy. So we have seen that if there is a dominant strategy in the set, support means support is nothing but set, right? So if there are dominant strategy in the Nash equilibrium, so we have seen that mixed strategy will not exist only. So we cannot have the existence of mixed strategy there. Therefore, D is तो पहले ही it is incorrect. if there is presence of dominant strategy, the set of mixed strategy will be a phi set. It will be a null set. देखो यहाँ पे, there is no mixed strategy here. So this is automatically gone. Point number D. Only when there is no dominant strategy, जब कोई भी dominant strategy नहीं होता, only then you see you are able to find a mixed strategy. Any other doubt in this? Okay, let's move on to the next question. Open up your mind, huh? Try to think as much as you can. Try to do the question number 2 now, based on monopoly. Try this one. Don't take more than 1 or 2 minutes. This is a very easy question. Okay, A. How about others? Okay. How can we do this question? There is no cost function given. But one thing I know for sure from the monopoly part. What is that thing? A monopolist always operates in the elastic region of the demand curve. Just use that property. This is the biggest hint. A monopolist always operates in the elastic region of the demand curve. Q is equal to 100 minus 4P. P is equal to 100 minus Q by 4. TR is equal to 100 minus Q by 4 into Q. 100 Q minus Q square by 4. Now there are two ways. देख लो यहाँ पे. But this is your AR curve. This is your MR curve. Right? When MR is 0, you have exactly your elasticity as unit elastic. You will always see MR equal to MC in this region. हमेशा यहाँ देखोगे कि MR और MC equal हो रहे हैं. It can be here, here, here. कहीं तो MR equal to MC होगा. Wherever that will happen, if you take that up, you will be operating in this region. It means that you will always be operating where your elasticity is more than 1, or where your MR is positive. You will operate where elasticity is more than 1, absolute value of elasticity is more than 1, or your MR is positive. दोनों में से कुछ भी लगा लो. You use anything, I am fine with it. Let's use the MR approach. MR will be 100 minus 2Q by 4. MR should be greater than 0. 100 minus 2Q greater than 0. 100 greater than 2Q. Q less than 50. My quantity can only be up to 50. this quantity that I have here, it can be up to 50. Which means that this is possible, this is possible, this is possible, but this is not possible. Right? You can go ahead and use the other approach also, which is fine. दोनों ही approach एकदम ठीक है. Right? So if I use my other approach just to show you, you could have gone ahead and you could have said, so Q is equal to 100 minus 4P. So dQ by dP will be minus 4. So elasticity of demand will come out as P by Q, dQ by dP. P ka value I just found out, 100 minus Q by 4 by Q into dQ by dP is minus 4. In absolute terms, if I have to find elasticity, so the minus sign will be gone and it will be 100 minus Q by Q. It operates in the elastic region. So 100 minus Q by Q greater than 1. 100 minus Q greater than Q. 100 greater than 2Q. Q less than 50. Gives you the same result. So either approach is fine. Just remember the diagram, both mean the same thing. Whenever your MR is positive, then your AR gives you elasticity more than 1. दोनों में से कुछ भी you can follow, it is fine. Okay. ठीक है. Let us go ahead to the next question now. Try this one. Go ahead, give it a try. Anyone? Okay, see. Okay. This is a very simple question. You can also do by the method of elimination. Eliminate the options in check. ठीक है. Let's check. First of all, utility function of Gita is given as min function. One property of the min function is that whoever has a min function will consume both the goods. It means that Gita in competitive equilibrium needs both good X and good Y. They are complementary good. वो एक को consume करके she cannot go ahead and she cannot survive. She needs both the goods. So, Geeta would need X star as something like this, M by PX plus PY, and would need Y star as M by PX plus PY. She would need both goods and equal amount. King pe hoga. Now look at the utility function of Sara. It is max XY. Now, one property of the max function is that you never consume both the goods. So, which means Sara is either consuming all of good X or consuming all of good Y. And we know she will always go for the good which is a cheaper good. Okay. And she will spend all her money on that good. Jo bhi good hoga, she will be spending all her money on that good. So, suppose she spends all money on good X. Then she is not demanding good Y at all. Just take some random case in your head. Suppose we know here that the endowment bundle is 5Y and 5X, right? So my endowment total amount of X is 5 and total amount of Y is 5. Now, if she spends all her money on good X, money she will consume some amount of good X. Suppose she consumes 2 units. I'm not even solving. I can just eliminate the option here. Suppose she consumes 2X. So X kitna bachega? 3 units of X will be left. And all of Y will be left. But will 3 units of X and all of Y be useful to Geeta? No. Because she needs equal X and equal Y. So market will not clear. Similarly, if she suppose consumes all her income on good Y, it means she will demand some amount of good Y. If she demands some amount of good Y, suppose she demands 2 units of good Y. Suppose उसका पूरा income से सिर्फ 2 units good Y का आ रहा है. Then we will be left up with 3 units of good Y out of total and all units of good X. Will this bundle be useful to Geeta? Again, no, because she needs equal amount of X and Y. So market will not clear. So whenever you have the presence of a max function with min function, market cannot clear. How will the market clear? Because she is consuming only one of the 2 goods. And she needs both the goods in equal amount. So if she consumes, suppose 1,1 and total is 5,5, you will be left up with 4,4. And she will only consume one of the 2 goods, X or Y. So market will not clear, market will not sustain. Which means that I cannot have any competitive equilibrium. And this should have been clear to you by practicing the different examples of general equilibrium. This is one of the most common result of it, that whenever you have presence of max function with a min function, there was no competitive equilibrium which was existing. So it means that here, जहां पे भी competitive equilibrium word आ रहा है, there is no competitive equilibrium that can exist. Competitive equilibrium is not possible. Market will not clear. So I don't have to find the price because I know that market will never clear for a max plus min function. Now the only option I'm left up with is there is finite number of Pareto optimal allocation. And I can prove that. So my Edgeworth box is 5,5. This is the origin of Geeta. This is the origin of the other person, whatever the name is, Sara. Now, Geeta's indifference curve looks like this, L-shaped. Sara's indifference curve also looks like this, inverse L-shape, but this is her origin. And we are asking which is the highest indifference curve Geeta reaches, given the indifference curve of Sara. That was what Pareto optimality meant. You have to reach the highest indifference curve given the indifference curve of the other person. So you start going up. And you coincide with the indifference curve of Sarah because both have the same king point. This also has the same king point and this also has the same king point. So all these bundles, they will be Pareto optimal. This is the highest indifference curve Geeta has reached, given indifference curve of Sarah. So of course, definitely this is all Pareto optimal points. But can we say that market equilibrium is attained? No, market will never clear for a max function when the other person is min. So the only option is B. That's the right answer to this question. Answer is B. Okay. Any doubt in this? Let's go to the next question. Try to do this one. Give it a try. Just tell me for bundle for option A first. Violets. Okay. Let's check. So I'm taking price here and quantity here. My price bundle is 1, 1, 2, 3. Quantity is 6, 3, 3, 5. Find the expenditure. 6 plus 3, 9. This is chosen. 3 plus 5, 8. So I can name this as Q1 and Q2. So when Q1 is chosen, Q2 is affordable. So I'll circle this. 6 plus 2, 12 plus 9, 21. 6 plus 15, 21. This is chosen. This is affordable. So when Q2 chosen, Q1 affordable. So when Q1 is chosen, Q2 is affordable. When Q2 is chosen, Q1 is affordable. That means it violates VOB. Check for the second one. 6, 3 at price 2, 3. 3, 5 at price 1, 1. Check for option number B now. Okay. So for option B, 6, 12 and 9, 21. 3, 2, 6 and 15, 21. So when Q1 is chosen, Q2 affordable. 6, 3, 9, 3 plus 5, 8. But when Q2 chosen, Q1 not affordable. So doesn't violate. What's the question? Which of the following is consistent with VOB? So answer is B. B is definitely consistent with VOB. It does not violate. That's correct. So you don't have to check C and D, but you can definitely give it a try. These should violate. Okay. Let's go to the next one. Try this one. Please, in these cases, remember the general formula. I don't have to waste my time in exam to solve again. You can remember the general formula. Okay. Others? What's the general formula of Q star? A minus B, A minus C upon N plus 1 B. A minus C upon N plus 1 B. The number of firms are 3. So each firm will produce A minus C upon 3 plus 1 B. A minus C upon 4B. But wait, this is the most important thing where you will make a mistake. It is asking total quantity. It is not asking quantity produced by each firm. Total quantity पूछ रहा है. So you need to find capital Q. It will be 3 times Q star. 3 firms है ना? So this is the quantity produced by firm 1, 2 and 3 separately. Total quantity will be firm 1 plus firm 2 plus firm 3 or 3 times this quantity. So it will be 3 A minus C upon 4B. Right? Which means that the only option that seems correct is C. I don't even have to find the price. Answer will be C. A minus C by 4B. Okay. So please read the question properly. You cannot make silly mistake in these simple questions. Okay. Now I am giving you this last question for the day as a homework. Give this question a try. You can consider this as a micro question also or a stats question because it's on probability actually, but on auction theory. Try to do this question. Try to post your answers in the chat or in the group, and I will check it. You can make a note of this question. An indivisible item is to be allocated to the highest bidder out of 7 bidders, subject to reservation price. Reservation price is only bids above this will qualify. माने अगर आपका bid reservation से ऊपर है, then you will get the item. Then you will not get the item actually, you will qualify to get the item. Then you will qualify to get the item. Bidders' value for the object are independently drawn from uniform distribution of 0, 1. So each bid is uniformly distributed between 0 and 1. If bidders bid their own valuation, so bid of each bidder is equal to their valuation. So bid 1 उसका valuation के बराबर है, bid 2 उसका valuation के बराबर है, and bid 7 उसका valuation के बराबर है, and valuation is uniformly distributed between 0 and 1. What is the probability item will not be allocated? So you need to find the probability item will not be allocated. That means find the probability in a way that they will be bidding. कब allocate नहीं होगा? जब उनका bid reservation से कम होगा, तभी तो allocate नहीं होगा. So you need to find the probability when item will not be allocated. Take this as a homework question. These are the options. Okay. Okay. So then we will meet for another marathon. I will post the topic in advance, किस subject का marathon I will be taking. And in the meanwhile, I request you to please go back and revise these topics. There are still a lot of silly mistakes that you are doing. So it is a good way for you to